This conference will now be recorded.
We hope to have an informative discussion here that's as concise as can be in respect for your time. You're speaking with Jim Tulin. I'm with Trace Environmental Systems, and as many of you know, we're providers of continuous stack monitoring systems. This particular session is about when and where to apply PEMS and when and where not to apply PEMS. Downstream of this meeting, at any time in the future, if anyone has a question or needs additional info, feel free to reach me at the phone number you see on your screen, or go ahead and shoot me an email with any comments or questions you may have. Just from a housekeeping standpoint, as Katie indicated, to minimize background noise, we're going to go ahead and mute everyone. And at the end of the session, we're going to have an open phone question and answer session. So we will unmute everyone at that time. We will also make available a replay of this. So for your own edification, or perhaps if you want to share it with a colleague, downstream of this presentation, we'll be letting everyone know a link to a replay of this. So if any of your colleagues were unable to make it today, they could certainly make use of it at their leisure in the future. So with that, we'll get right into it. We, as I mentioned, are going to try to keep this as brief as possible out of respect for your time. And we're going to touch on the topics you see on the screen here. We'll first give you a nickel tour of who Trace is. We'll talk about CEMS versus PEMS. We'll talk about the EPA and state acceptance of PEMS. We'll talk why would you use a PEMS, and further, why would you not use a PEMS? And then we'll get into some of the mechanics associated with deploying a PEMS, and what are the best applications to deploy a PEMS on, and then why you might consider us as your solution for your PEMS needs. We'll offer you some questions that we've been posed in the past, and then also we will open the phones for your real-time questions. So I would ask during the course of this presentation, if any questions pop into your mind, go ahead and jot them down, and make sure to feel free to pose them at the end of the discussion here. I'm joined by our Chief Engineer, Dave Martin, today, and Katie Lindblom is also on the phone. So as questions are posed or throughout the presentation, if any comments that Dave or Katie feel are pertinent and relative, they'll be joining me as well. So with that, quickly, Trace, as many of you already know, we're approaching our 25th year of business, and we've been doing nothing but providing continuous stack monitoring systems. It's broken down by hardware-based systems, the traditional CEMS approach, and for the last 10 years or so, we've been also providing PEMS, which is a software-based solution for continuous stack monitoring. In either case, whether we deploy a CEMS or PEMS, we're also providing our own data acquisition handling reporting software. We have a team of field support and remote support personnel to help with ongoing issues. And we also manufacture and provide our own stack flow meter, which is fully PS6 compliant for CEM applications. So very quickly, many of you have seen or are operating CEMS. They'll typically come in their own climate-controlled shelter or in their own freestanding cabinet, such as those provided by Hoffman or others. In this particular case, you see a climate-controlled shelter at the base of the stack with the umbilical going up to the catwalk where the probe resides. As I mentioned, you also have CEMS that come in freestanding cabinets. We are very strong proponents of CEMS, so it's important that it be recognized that we're not necessarily pushing PEMS at the expense of CEMS. We really consider ourselves to be an objective stack monitoring solution provider, and we'll go ahead and recommend the best approach based on the particular application. We have our CEMS installed at over 400 facilities in most all 50 states at this point. We're the market leader in several different industries and do a lot of work in central utility plants and universities and sources like those. So as you folks know, a CEMS is typically made up of a bunch of hardware components: the probe, the heated umbilical line, the cabinet or shelter, the analyzers, pumps, sample coolers, PLC, solenoids, rotometers, cal gas bottles, the CGA bottles, regulators, wiring, plumbing, etc. Whereas a PEMS is basically made up of PC and software. And of course, the software on that single PC is basically the PEMS modeling software, along with the data acquisition reporting software. So just from the standpoint of what makes up a system, heck of a lot less components in a PEMS approach. As a result of that, the PEMS typically offers some pretty significant operational cost savings because you have no hardware to maintain, there are no spare parts, there are no daily cal gas bottles, there is no analyzers, so there are no analyzer failures. So this equates to significantly reduced time for your operators and your I&C technicians, as well as not needing the call-outs of a CEM technician that you might bring in on a scheduled or an unscheduled basis. Common to both solutions, though, whether it be a CEMS or a PEMS, is the data acquisition reporting software. And we just show you a quick screenshot of one of our applications that we have deployed with our data acquisition software. So irrespective of it being a PEMS or a CEMS, the same data acquisition reporting software is used. And indeed, we have instances where at a single facility, our single data acquisition software is handling the data for a hardware-based CEM as well as the PEMS. So the software really doesn't care. So getting into the regulatory aspect of this, as many of you know, taking a boiler, for instance, those at or greater than 100 million BTU per hour heat input capacity are subject to subpart DB of 40 CFR Part 60, and therefore need to continuously monitor for NOx and O2. You'll see some regulatory agencies also requiring CO. But in many instances, when a permit is issued for such a source, it will read something to the effect that the monitoring shall occur with the use of a CEM or an approved alternative methodology. And when you see that, that means PEMS.
Hey, Jim, if I may, 40 or subpart DB is one of the first places where PEMS was specifically called out as being acceptable, and that has been the case for a number of years. So it has been used, I wouldn't say extensively for subpart DB, but widely.
That's a very good point, and many of our applications are meeting subpart DB requirements in many different states. So long about 2010, the US EPA promulgated Performance Specification 16, PS16, which basically codified the way in which PEMS shall be deployed and operated. And from that point, the stamp of imprimatur was put on the use of PEMS by the US EPA, and we've seen more and more PEMS being deployed since that point. Suffice to say, our PEMS fully meets Performance Spec 16 requirements. So why would you use a PEMS? Well, cost. As we all know, a continuous stack monitoring system is a regulatory-driven device that adds nothing to the bottom line of the user. It is basically a cost. So if you can achieve the regulatory compliance and the reliability and do so in such a way that saves internal and external costs, it might make sense to at least look in that direction. So the upfront purchase price is plus or minus 20% or so of a CEMS. And added to that is the fact there are no physical Installation costs. Well, I shall say minimal installation costs. Whereas with a CEMS, you're getting an electrical or mechanical contractor to physically install the system, run wires, run utilities such as power and air. Very minimal such costs exist with a PEMS because you've simply got a PC and then the comms wiring between it and perhaps the plant control system. Beyond the upfront cost savings, where the real cost savings occurs is the operational costs. And that is accruing year after year after year. By way of example, if the typical life of a CEM is plus or minus 15 years, and you've got $10 to $15 to $20,000 of operating costs that you're savings by using a PEMS instead of a CEMS, you can see that adds up to significant dollars over the life of a typical CEM system. So where are you saving those dollars? Well, whatever dollars you guys presently allocate for daily calibration gases, whatever dollars you allocate for spare parts, for scheduled PM or emergency basis, whatever internal costs you assign to your technicians for the care and feeding and upkeep of a CEM. And whatever dollars you allocate for the periodic need to bring in an outside technician from a CEM vendor, perhaps. Those costs largely go away. And if you add those up and multiply them by 10, 15, or 18 years of the life of a CEM, you can see the lifetime savings for the use of a PEMS versus CEMS is not insignificant. So getting into the nuts and bolts of how a PEMS is deployed, basically when a new source is on site, it's important that be fully commissioned, lined out, and tuned before we do our work relative to the deployment of the PEMS. So once it is all tuned, we'll go ahead and deploy a temporary CEMS in a trailer, much like you'd see in a stack test trailer. And we deploy that for a period of time ranging from a week up to 3 weeks or so. And during that period of time, we're monitoring the emissions of NOx, CO, O2, etc. We'd like to see as many operating conditions as we can over that period of time, the ideal being a startup and a shutdown being included, so that we're capturing stack emission data against most all operating conditions that the source might see. Now, in many instances, whether it be a boiler or a turbine, in real life, it comes up and it runs at steady state and away it goes. But for the purposes of us developing an ideal model, we'd love to see as many operating scenarios as we can in that couple-week period that we're initially pulling in the data. So the temporary CEM actually monitors the stack emissions, and we store the data on a 1-minute basis over that period of time. Simultaneous to that, and in parallel, the plant control system, whether it be a SCADA or DCS, is also monitoring and collecting the process parameters from the boiler or turbine, the typical parameters you might see from a source like that, such as fuel flows, temperatures, pressures, damper positions, operating statuses, things of that sort. So once we've got the stack emission data for that period of time, along with the process data from that period of time, we put the two together and we create our PEMS models. This is part of the engineering and the configuration process that takes place as we go to deploy the PEMS. We have or will establish a communication handshake between our PEMS computer and the plant control system, and we typically do so via some open protocols such as OPC or Modbus. So all the time, in real time, we're handshaking and sharing data back and forth between our PC and the plant control system. And the control system is feeding us real-time values from the boiler or turbine, such as the fuel flows and temperatures and pressures I alluded to earlier. And then we'll oftentimes send signals back if their operators want to see real-time values of NOx or CO, or if they want to see alarm statuses or things of that sort.
Hey, Jim, if you don't mind, let me kind of just step in here for a second. I just want to make a comment about PEMS versus CEMS. We know what a CEMS is. We can see the CEMS. We know where the cost is. It's in the analyzers. It's in the chiller. It's in the probe. It's in the umbilical. It's in the PLC and the like. But what Jim just covered is really where the bulk of the cost of a PEMS comes in. So in other words, the PEMS is it's hardware light, but very engineering heavy. So there's a lot of time and effort spent developing the communications between the data acquisition hardware, the DCS system or the SCADA system, and then to collect that process and that CEMS data and turn it into a model that can accurately predict the future emissions. That's where the real meat of a PEMS comes in. That's where the cost. It's very engineering heavy.
That's a good point to raise. When you say, boy, if there's such little physical stuff associated with a PEMS, why on earth isn't it more than 20% lower on the initial purchase price? So partly the answer Dave just gave speaks to that. Moving on, once the commissioning is complete, it's important to note that the ongoing QA/QC requirements is very similar between a PEMS and a CEMS. So while you're seeing some significant cost savings associated with the parts and no daily cal gases and little or no failures and no replacement needs for analyzers, et cetera, you will still see similar costs associated with the ongoing QA. So by way of example, once our PEMS is fully commissioned, it must undergo an initial RADA, just like a CEMS does. So in this particular case, the initial certification is made up of a 3-load RADA, having to meet a certain relative accuracy. It undergoes the F-test, the bias check, correlation analysis, and then on an ongoing basis, much like a CEMS has to undergo cylinder gas audits on a quarterly basis, the PEMS must undergo a relative accuracy audit, an RAA. We can describe that in more detail if you like, but pretty analogous to a CGA. Whether our technicians do it or your plant technician does it, 3 quarters out of a calendar year, this must occur, just like a CGA must occur. And then once per year on an annual basis, the RADA must occur again. So your quarterlies and your annuals are pretty similar between a CEMS and a PEMS. So we've talked about the merits of deploying a PEMS and what benefits you might derive in using it, but it's important for us to note where you should not try to deploy a PEMS. And as I mentioned before, as an objective solution provider for continuous stack monitoring applications, we're not in the business of trying to shoehorn a PEMS into an application that could cause us all a lot of heartache and cost. So we're very judicious and conservative on where we like to deploy PEMS. For instance, we do not want to deploy a PEMS on a solid fuel source, whether that be coal-fired or biomass-fired or garbage or refuse-fired boilers. We shy away from those applications that run on gas whose concentration varies. Perhaps you've got a pipeline natural gas-fired source that's supplemented by a waste or a syngas, might cause a little heartburn with a PEMS. Sources with fuels that have unknown or varying heat content pose challenges for PEMS. So if you've got number 2 fuel oil, or if you've got pipeline natural gas with basically a known heat content, that's a home run. I would also say that while we have deployed PEMS on sources with varying operating conditions, it is a challenge. So the ideal source would be one that is relatively steady state. So depending upon the operating conditions of a source, we'll make some judgment calls accordingly. So I mentioned the word ideal. Without question, the best place to deploy a PEMS is when it's replacing an aging CEMS. And there's a couple reasons for that. Firstly, there's minimal risk because we can deploy the PEMS and it can operate for any period of time you like in parallel with the CEMS. So fully debugged, fully commissioned, established solid data that can be compared to the CEMS over a month, a quarter, 2 quarters. So we know the PEMS is absolutely operating in a terrific fashion before we quote unquote turn the CEMS off. And the second thing is when we are replacing an aging CEM system, we are making use of 3, 5, 10 years worth of historical data that CEMS has created over time, and using that to create some very robust models within our PEMS. We'll also take a like amount of time data from the plant control system and use it to really create a robust model that has seen a lot of different operating conditions, which is a terrific solution for the PEMS. So if you do have interest in PEMS, you know, what is the purpose of considering Trace for that? Well, we're pretty objective. We don't really have a dog in the fight. We need to make sure that you meet your regulatory compliance requirements for continuous stack monitoring. And we've got a couple solutions to do so. PEMS is simply another arrow in your quiver to try to satisfy this requirement. It's not the be-all, it's not the end-all, but it's a darn good solution in the proper installation. When properly applied, it works very well. So we bring that objectivity to it. We've also deployed a number of PEMS over the years, and we've seen a lot of scenarios, a lot of operating conditions, a lot of different permits, and we've met them. We also bring to the table our inherent expertise on regulatory stack monitoring compliance requirements. And we're also fully integrated. So we've got our own data acquisition reporting software that sits right on top of the PEMS, and it makes for a nice turnkey solution for end users. So that largely concludes the presentation portion of it. I did want to share some questions with you that we've been posed over time, and maybe this can stimulate some questions as well from your end. We'll be opening the phone lines momentarily for any questions you folks have. One question we've had is, do additional process instruments need to be purchased by you in order for us to provide the PEMS? Must there be additional process instruments that give us adequate process signals? And the answer to that is no. In all the instances we've deployed PEMS, those process instruments that come with the source, you know, the Cleaver Brooks boiler comes with pressure and temperature sensors. It comes with flow sensors. The fuel flows to that boiler are measured with a flow monitor. So those typical process monitoring devices are sufficient for us to bring into our PEMS and do what we need to do without having you purchase extraneous or additional instrumentation. Does my state DEP accept PEMS? Dave may be able to speak further to this, but the fact is meeting US EPA 40 CFR Part 60 Subpart DB, while it is a federal requirement, the state agencies are simply agents of the US EPA. And we have found acceptance throughout the country on the state level for the use of PEMS.
I would say, Jim,
Dave, do you have any other comments to that?
Well, I would say that New Jersey is hesitant on accepting PEMS. That's the only circumstance I've found where there's a state problem with PEMS?
So it's depending upon where you are. It's a case by case basis, but as Dave indicated, if you're in New Jersey, that's something that may need further discussion. But the likelihood of your state agency not accepting PEMS is quite low. So if the PEMS is dependent upon these process parameter monitors, what if one of those monitors fails? What if the temperature sensor fails or the pressure sensor fails? Well, in our particular case, we categorized the process parameters into 3 tiers: Tier 1, Tier 2, and Tier 3. And it's based on their correlation coefficients with the pollutant levels. So we take those process instruments as part of the engineering Dave described earlier, those with the highest degree of correlation to the pollutant parameters are put into Tier 1. Those with the second best correlation are put into Tier 2 and so forth for Tier 3. Well, if one of the Tier 1 components fails, our PEMS software automatically flags that and elevates one of the parameters from Tier 2 into Tier 1. And we make use of that. Once that primary instrument is repaired, it goes back into being one of the Tier 1 parameters used. So there are inherent levels of security that the PEMS deploys, where in a CEMS, if an analyzer fails, you're out of luck. With the PEMS, we've got multiple layers of security that the PEMS still operates well in the event of process instrument failure. The other question we've gotten is, how do we achieve communication between the PEMS and the plant control system? As alluded to earlier, it's most typically done via an open protocol such as OPC or Modbus, and that's down to the detailed engineering that Dave alluded to earlier. That is part of our project scope. Our and lead engineer on the project will get with your instrument engineers and will determine what the best means is for that bidirectional communication to be achieved. We've also been asked if there is ongoing support for the PEMS, and there certainly is, whether it be remote support in the form of phone or remote login support, or we have a team of field support personnel going around doing monthly or quarterly PMs. And in the particular case of a PEMS, we actually conduct the relative accuracy audits, just like we do the CGAs for CEM systems. So I would say, just to remind you that if you have no questions that come to mind, please, at any time in the future, feel free to call or send an email with a question. But at this point, Katie, I think it would be good if we could open up the phone lines and see if anybody's got a particular question that they want addressed at this point.
Any questions, folks?
Sorry, Jim, I did just open the lines, and we did have one attendee that texted me or sent me a chat of a question. I'm happy to read that right now. What if you have key fuels, such as natural gas and propane? We switched to propane during curtailment.
Yeah, let me address that, Katie. Jim mentioned in there varying fuels of varying heat contents, and I would say that's right and it's not right. The real issue is fuels of unknown content, heat content, or whatever is in those fuels. So where we get concerned is where it might be like a landfill gas that would be used to supplement a turbine. And that landfill gas has an unknown heat content. Could vary from anywhere from 880 BTUs per standard cubic foot up to 1,000. And it's and by the way, its hydrogen sulfide content could vary significantly, and there can be all kinds of issues that happen in that scenario. So, in my experience, switching between two known fuels, as long as you can fully characterize the system during the switching and how much of each fuel there is, then you're going to be okay. But you have to do a lot more upfront work in that scenario, because you have to see it with, at this load, now move the boiler 10% propane, 20% propane, 30% propane, and then now move to the next load and go through the varying propane loads. Now go to the next load, varying propane loads. So the upfront work may be significantly more, but once you do that work, the PEMS would be able to handle that.
Dave, so I have another attendee that asked, what if you have both fuel oil and natural gas that may be blended during operations?
I would give you the same answer I just did. As long as we're not, the only problem with fuel oil is if we are monitoring SO2. If we don't have to, under the permit, monitor SO2, then I don't worry about it. SO2 is a difficult issue for a PEMS, because where do you typically have to monitor SO2? You have to typically monitor for a solid fuel situation, and generally the fuel largely has an unknown SO2 content. So as long as we're not monitoring SO2, I wouldn't be concerned about it.
So any other questions that come to mind at this time, folks? Please feel free to speak up, and we can also entertain questions via email or phone anytime downstream of this as well. Okay, I think there being no additional questions, I think we'll wrap it up at that point, and I want to say thank you very much for your time, and we'll speak to everyone soon.
Thank you.
Thank you.
Thank you.
Bye-bye now. Bye-bye.